Assalamualaikum warahmatullahi wabarakatuh. For today's session, which is the Oscillatory Motion, Chapter 15. So to start with this idea, we need to understand and look at what we call as spring. That's number 1. Number 2, and what is simple harmonic motion. For that, let's watch a video. In this video, we are going to look at what we call as simple harmonic motion, which is the baseline of understanding for this chapter 15. So the first one is simple harmonic motion is a periodic motion, is a repetitive motion. So what is repetitive motion? For instance, traveling back and forth to the right, to the left, to the right, to the left. So that is a repetitive motion. However, for that repetitive motion to be what we call a simple harmonic motion, therefore, it must obey two things. So what are those? Okay, so this is an example of what is a simple harmonic motion. Now, a spring attached to end of it, a mass, and then we displace. So as we displace, we find that the mass now will be traveling back and forth, a repeating process. However, take note that there must be, where the spring constant is with unit Newton per meter. And spring constant is the amount of the stiffness belonging to the spring. Getting back to the book. So what is simple harmonic motion? Is a repetitive motion. However, not all repetitive motion or periodic motion is what we call as simple harmonic motion. Now, when object is called consider as simple harmonic motion, therefore, it must, number 1, obey what we call as Hooke's law, and number 2, that the acceleration of the block must be proportional to the position. To get this, MA is equivalent to negative kx from Hooke's law just now, the force. And then rearrange the situation, you find the acceleration is dependence on the displacement or position. Displacement or position. So you find that the A keep changing in terms of the value. Alright. So you find as well that acceleration will turns out to be 0 whenever displacement is 0, or the opposite, when displacement is at the maximum displacement of what we call as amplitude, then what happens is acceleration will be the largest. Okay, when we talk about speed, it's the other way around. So speed at the location where displacement is at the maximum, speed turns out to be 0. So same as what you learn in free fall. Pada highest point of U-turn, you find it has 0 speed. While the maximum speed will occur at x equivalent to 0. So remember the tips that it must be opposite of acceleration. When acceleration is 0, then speed would be at the maximum value, and vice versa. So before we proceed for the next subtopic, just go back to what is simple harmonic motion. So acceleration proportional to the position because A and X. And the second condition is this one, acceleration is opposite in the direction. How do we arrive with the term opposite? Because of the negative. Opposite to the direction of this displacement from the equilibrium. Right, the use of knowing what is simple harmonic motion, what is the definition of simple harmonic motion is that whenever you are given any system, or any motion that is repetitive, you have to look, is there category ataupun characteristic, these two characteristics in the motion. If you find that it's there, then you can categorize it as simple harmonic motion. You have a graph of sine curve to portray the position with time. Now, that video just now just explain why do we have the sinusoidal graph of the motion. Okay. Now, something to recall from physics previous class of physics 1. Okay. Do not worry much about this one. Okay. You find that a graph, this equation is given the equation sheet. However, there's a slight difference here, which you will find there is phi, PHI, symbols here. This is actually a corrections made so that it fit into the original cos figure. Okay. Now, you find as well, whenever you do dx over dt, the whole expression would turns out to be v. Differentiate it and look at how it turns into one another. From cos, when you differentiate, becomes sine. Sine, when you differentiate, become cos. And again, I would like to repeat, don't worry much about this expression. This is given in the equation sheet. Right. Now, what is A? A is the largest displacement, which is called amplitude. What is omega? Omega is angular frequency. Okay, angular frequency. And all these three values are constant. Maknanya adalah satu simbol yang sama nilai in an expression. They have different value, but overall, as you repeat the expression, write it with different time, you find that there has a specific value. Now, the benefit of this expression, where displacement, or sometimes in this textbook use position, varied with time, okay, is whenever you have a specific time that you would like to identify, so substituting the time into this expression will give you the positioning, the speed, and even the acceleration value. So that is the use of these three expressions. While the earlier expression, whereby if you can recall back, that acceleration is at the same time, can be calculated by using k x over m, will allow you to find value of acceleration as well. However, with the given or known value of positioning. So there are two methods basically. This requires you to have the time substituted. This is positioning. So it's just two methods. Alright, so before we really try it out, a few things that we need to take notes. Okay, number one, just now we have looked at the idea of amplitudes. Number two is angular frequency. Recall the angular frequency that you have learned in physics 1 is 2 pi f. However, it's also correct to write down omega here as square root k over m, and recall that k is a spring constant. Okay, and the additional just now, pi here is called as phase constant. Now, the idea of the phase constant, I could straight away tell you why it's there. Now, this expression shown in figure 15.3 specifically shown that when time is equivalent to 0, the displacement is at the amplitude. Now, by substituting t equivalent to 0 into the expression of the earlier, which is this one, x is a cos omega t plus 5, logically you should find that your 5 just now should be equivalent to 0. This should be equivalent to 0. Why? Because cos 0, and this is supposed to be a as well, it must be this one 0 as well. And that's the whole idea. Understand? So it really depends on the shape. This is this one. So mathematically, this particular graph of 15.3 is purely or can be written without the 5. Dia sebenarnya adalah semata-mata x a cos omega t alone without the phase constant. So that's the reason why I did earlier mention that 5 tu adalah correction made supaya dia fit menghasilkan bentuk cos tersebut. Okay, so what is angular frequency? These are the expression. Please take the time to jot it down properly inside your notes. Alright, what is a period? Now, what is frequency? What is a period? Now, period is the time taken to complete one cycle. So, for a cycle, untuk kita tengok cycle dalam bentuk figure here, it must look something like this. You start at amplitude, okay, and it should end at the amplitude. This one. Okay, so this is the I call this as one big cup. Okay. Now you can observe it in different view as well. If you tend to start with 0, you should find that it also stop at 0, but here. So it will look something like this. So this is what I call as two small cups. Now both the time portray here to here are equivalent to one another, and we call it as one cycle or one circular motion, one periodic motion. Okay. So that is what we call as period. So how does period related to T? Recall back that frequency is 1 over T. Okay. Now let's turn to page 390. So this expression, display expression from 15.10 up until 15.14 are modified expression from what you have seen earlier, that I have shown earlier. What is periodic, what is frequency, what is omega and such. Alright. And again 15.15 and also 15.16 is actually given in your equation sheet. Alright. So this is something new. Okay, we are given earlier that you can calculate acceleration by using maximum acceleration. Let's look at the maximum acceleration by using km over a. This is from the Hooke's law. You find that there is no negative given here because we are interested in terms of the value. So negative is thrown because we are interested of the value. Okay, not shown because of we are interested with the value sahaja. Okay, not that it's wrong. You can have it together with the negative, but we are already indicating that we like to know what is the value of acceleration. So it's just okay not to have the negative here. Alright. On the other hand, okay, we find that Vmax is given in such odd expression. Okay, let's visit this expression. Okay. You have earlier another expression where displacement is jotted down as A cos omega t plus correction, which we call as 5 ataupun 5 to symbol phase constant. Alright, so when we have expression as such, kalau kita want it to be a maximum value, then mathematically this whole thing of product sign, idea is very simple, that the whole thing of a product of sine omega t plus 5 ni must be equivalent to 1. And that's the reason why they jot it down considering only the omega and a. And again, negative is not shown because we are interested with the value. So maximum velocity, maximum speed, we are interested in again the value. Now let's turn to page 391. Our task here is to look and study these three graphs, and we are going to identify is it really true or how do we even get the V maximum and X. Okay, so amplitude is the largest displacement. So this is what is amplitude supposed to be. So if it's displaying 5 centimeter over here, then amplitude is 5 centimeter. That's how it works. Alright. Likewise, the peak for the second graph, which is shown here, labeled as V versus T. Therefore, the Y value adalah V maximum. Okay. And same goes with the acceleration graph. Okay, something to ponder. Previously, I did mention that the V maximum occurring at the equilibrium. Look at how when it is at the equilibrium, yes, V turns out to be maximum. However, acceleration turns out to be 0. Okay, our task is we need to know how to sketch the graph. How to sketch the graph. The best technique is start sketching from here. When as if there is no phi. Okay, as if there is no phi. So I'm going to throw away this portion. So you're going to see some sort of a pattern. Pattern ni supaya awak boleh faham dan boleh draw on your own. Now this is the original X value. Original tanpa ada yang merah ni. Saya buang. Okay, now so considering phi tak ada. So betul-betul purely cos sahaja with phi constant is equivalent to 0. So you find that the shape during one period, peak to peak, would look something like this. Okay. The velocity kita ambil 1/4 of the original X to draw dia. Look, 1/4, this is 1/4, 1/4. You have ni, bahagi kat 4, so ini 1/4 dia. Now, what's left over as this one? And keep continuing it, no problem at all. So, look at where it starts. Buang 1/4, throw away the first quarter. So, whatever left would be the shape of the V versus T. What about acceleration? Look at the graph of V, throw away, take away, delete 1/4 of the V. So look at what's left. It started here. It started here. So this is where it starts. Okay, I hope the tips given just now helps you knows how to draw. Your task now, you can go to figure 15.7, a clean figure here. Look at how it takes away the first quarter. Yeah? So period is from 0 until T here. Divide it into 4, ambil 1/4. Look at how the X graph turns into V, and again take another quarter of V, turns into acceleration graph. Alright, in this portion, in this video, we're going to look at examples given of the book. In this example of 15.1, we're going to see that a few terms that you have seen earlier, for instance, omega, period, angular frequency, period, maximum speed, maximum acceleration, and even the expression of sinusoidal. Okay, we're going to learn how to substitute things into it. Alright, so you find that 200-gram block. So this is the mass. So I'm going to convert it. Next to it, I'm going to jot down M so that we can go back anytime and for us to remember. Force constant, K value, free to oscillate on a frictionless surface. So obviously this is simple harmonic motion. The block is displaced from equilibrium and then release. The moment that it says it release, this is an indicator, a value, which is amplitude value. Now, find periods of its motion. So, your first task is you need to know what's expression to be used. Okay, you could either use, okay, I have another version that I like you to try out. I call this as tamak. You will find that this is very helpful in terms of memorizing. Tamak. Okay, 2 pi square root m over k. So aside as using given expression shown here, you can as well use this version. Observe that there is no a amplitude in this equation. So you will find after this that amplitude does not provide you the t. It does not influence it. So it purely coming from the mass and also the k value. So that's how they substitute. Alright, now that's the next one. Maximum speed of the blocks. Okay, so asking maximum speed, you have two options. Okay, in this case, they give you this expression that omega times a. If let's say that you don't remember, go back to this expression that v in terms of the time, when time is varied, you are going to jot it down as negative omega a sine omega t plus with the correction of 5 or phase constant. So since it's the maximum value, we are only interested with this version only. Okay, omega a, and not the negative as well. So that's gonna how, and look at the units, still the original unit that you learned in previous class, which is speed should be meter per second. The next question, maximum acceleration. So yes, you can use this expression, omega squared. So given here omega just now is the one you have calculated earlier, okay, or you can use term omega as 2 pi f from your physics 1, or 2 pi over t, okay, over t. So you can use the t 1.26 just now. So 2 pi divided by 1.26, okay. So this one is 2 pi divided with 1.26. It's equivalent to the omega just now times with the amplitude. On the other hand, can you remember we have another version? Yes, that you can use kx, Hooke's law, without the negative, because we are only interested in the value and ma. So just substitute that a is the x value. Express the position, velocity, and acceleration as a function of time. Now, in this scenario, we find the case is at time t0, displacement occurred at a positive a. So that's the reason why the expression is with 5 equivalent to 0. Or writing it down, this is 0. So purely this version. Okay. Another way of writing is you can substitute together with the unit 0.05 with the unit over here and then with a bracket. Okay. Why is it that sometimes there is no bracket like this one? It's together with the bracket because this is purely on its own, kan? So definitely the eye, mata kita boleh nampak bahawa 5 kali T kena together, combine together. So to be on the safe side, I would suggest go with the bracket because we are the one who are going to substitute into our calculator. So let's say that we put on our calculator cos 5 times whatever T you are interested, then you'll get stuck. It needs together with the bracket. Kena masukkan bracket bila kita masukkan dalam calculator. Alright. So, give a try with your own calculator. Did you arrive with this answer of 1.25, 0.25 and including the T and such, yeah? Alright, there's no need for the what if. Now, let's look at example 15.2. But before we start, I like to remind you it's very rare that the question comes in this version, but the aim of this example is to let you understand more and get close with the mathematic version when it involves sinusoidal. Okay, for this version as well, you need to have trigonometric function. Okay, it says here if a sinusoidal graph that started with x time equivalent to 0 at x at the amplitude, so the graph would look something like this, which is the red color. You are to find a general expression when x is equivalent to 1 over 2. So the aim is, this is the general expression. Let's substitute x equivalent to half of the amplitude and then simplify it to get t. Okay, so this is our main expression yang kita nak study. Okay, our main expression. Once we identify some value of the omega and such, okay, we're going to substitute into this expression and from there we can solve it. Okay, so ini kita punya core dia. Stop here. Okay, coming back to this graph, when is it that it's 1 over 2? It should be somewhere here. Okay, mathematically proven that it's occurring at pi over 3. How did I arrive with pi over 3? By substituting half a as the displacement, I would arrive with t equivalent to inverse cos 1 over 2. Cuba masukkan ni dan kita akan permudahkan bagaimana dengan cancelkan a dan kita akan dapat t equivalent to this product. However, considering that this is cosine graph, you must remember that you need to convert your calculator to radian mode. That's number one. Number two, because this is a case whereby it's inverse cos graph, you should find that the positioning would be 2. Okay, so this is number one here. This is number 2. Okay, I didn't yet explain you how do I get pi over 3. Never mind, hold on. So this one, if this is pi over 3, this is also correct to have 2 pi minus pi over 3. Okay, which you will arrive with equivalent to 5 pi over 3, which is this one. Okay, let's get back here. So by referring to trigonometric function, okay, 1 over 2 is actually equivalent to pi over 3, okay, or 60 degree. 60 degree. That's how I arrive with this product. Okay. Now, in order to get other position in during the next cycle, so add on the next cycle, which is called as 2 pi n. Maknanya katalah the next first cycle after this, masukkanlah n sama dengan 1. Understand? And 2 and the next and the next. Okay, that goes the same why we add with 2 pi, another cycle, the next cycle onward. So bila kita simplify, we have this expression. Alright. Okay, ini t. So what we are going to do here, okay, we are going to substitute the value here. Okay, now inverse cos 1 over. Okay, let's just get back here. Okay, at the same time, we acknowledge the generic expression just now, which is 1 over omega just now. This is the omega. Okay, alright. Okay, how do we arrive with 5 here? We need to go back to example 15.5. Okay, yang ini adalah example 15.1. Sorry, 15.1. Alright, so this cos negative 1 over 2 is this one. Okay, so it's as if t gets into t. That's what's happening here. And then when we simplify, we arrive at this one and this one. Alright, now my aim on this one is not much. My aim is for you to understand, number one, how that during one cycle, there are 2 times that object will reach the same position. Okay, repetitively the same position, and that's how it looks like in terms of here, both, right? The rest just mathematic version. And again, I don't remember seeing this type of version in the final. But again, it's meant for us to increase our knowledge and understanding. Alright, give it a try.